So hi, I'm very happy to be here to talk about Angular with JHipster. I'm gonna talk about what we've done, all the amazing work, all the teams have done to improve your Angular experience with JHipster because I love Angular. So my name is William Marques. I'm 24. I was a trainee with monitoring man Pierre. So I work for Ippon. I am a part of the JHipster core team also, and I am a JavaScript lover. And you can reach me on Twitter if you have questions after the talk. So I'm going to remind you the JHipster objectives for the front parts, but we can apply some of the points for the whole project, I think. So we want to keep the configuration as simple as possible, so we can tweak it easily if you want. We want to provide you the best practices from the guy when we can that works on the technologies from Cache, Spring, or Angular, or Webpack. We want to make your production build for the front parts as small as possible. I will tell you why it's important later on the talk. And we want to make your development workflow very fast, so you can easily develop and you don't waste a lot of time waiting for TypeScript, for instance. So, what did we do during the JHipster 5 making? We first upgraded to Webpack 4. Then we set up the lazy loading in Angular. We also added some optimizations. And finally, it's pretty recent, we migrated to Jest from Karma. So, Webpack 4. What are the main announced features of Webpack 4? First, it should be better performances, and by better performances they mean faster build times, and also an easier configuration because the Webpack configuration was quite messy, and I don't think a lot of you understand it well. Even for us it was difficult to configure Webpack. So they made some presets for development and production modes in order to provide you some default configuration when you start your project. So it's easier for you to tweak your configuration after. So in fact, what are the metrics we have for the JHipster 5? I generated two white applications, and ran various commands. First, I tried the basic command yarn start. We've gained around 5 seconds for the first build. And then when you save a file, we gain a lot of time. We went from 2 seconds, which was a bit long, to 0.7 seconds, which is more acceptable. But as you can see, we lost a lot of time for the production build. We are investigating this little issue for the moment. We will try to make the production build faster, but we gain around 1 megabyte for the final bundle. So you lost some seconds for the production build, but you gain a lot of size. And I think what really matters for your client is the final bundle size and not the time you lost while bundling it. So, but we will try to improve it. It seems that is the Angular compiler who takes a lot of time to process all the TypeScript files. So, but we try to improve it. So, who here knows how to configure Webpack, or at least who understands a Webpack configuration file? Okay. So let's check. I won't dive deeply into the configuration, but I just want you to show the major parts. So if you don't understand something, or if you want to improve something or change, at least you will understand the configuration, so you can change it and maybe make contribution. So I'm going to show you the production because for me it's the most important one. Do you see? Let me close. That's okay. So Webpack is different from Gulp and Grunt. Gulp was just a task runner. Webpack is a module bundler. So a module bundler works with an entry point. You will say, well, my application starts in this file, or you can specify more than one file, and then he will check the dependencies up and up again, and will make a dependency graph, and then he will bundle all this code into various files with some optimization. So you have to first specify the entry points of your application. It can be JavaScript, TypeScript, CSS, anything you want, just entry files. And each entry files, we have at least one output files. So just specify the entry. Here you have the polyfills to make sure your website works on all the browsers. You have the main style sheet. You have the entry point of your Angular application. And here we tell Webpack, okay, when you finished all your work, put all those files in this directory, and you will use a hash, so your client won't have to empty his cache. I know it's the first thing we say to our QAs, empty your cache, retry, yeah. So here he shouldn't have to empty his cache because if you modify your code, you will have a different hash, so it should solve the problem. And a chunk is a file that is created by Webpack when he sees that he can separate your code into a different file. It's used when you do lazy loading, for instance. If you split your code into another file, Webpack will detect that and say, oh, okay, the user can't wait for this file, so he will bundle it separately. Here you have the module part with rules. They are regular expressions. I'm not a big fan of regular expressions, but they are pretty easy, so it's easy to understand. So you just test for this line, the extension of the file. If I want to import a TypeScript file, for instance, you will use this tool to process the file and transform it into JavaScript file that the browser can read and interpret. For CSS, we use a CSS loader. The loaders are used in the reverse order. I don't know why, but he will use first CSS loader and then the toString loader. And that's it for the other files. I can go into the dev configuration. You will see you have the same things. For TypeScript, in the development, we will use, before doing compilation, the TS-lints to check that you have no error in your TypeScript file, but you have the point. For production, you have an optimization field to customize if the Webpack defaults doesn't suit you. You find your bundle is always too big. You can optimize more your packaging. For example, you can use Minimizer to customize the Uglify JS plugin options. This plugin will mash your code into to remove the unused code, the comments, or some lines that will never be called. They will remove it so your bundle is always smaller. And then you have the fourth most important part, which are the plugins. The plugins are all the things that a loader cannot do. So mostly it will be things that happens after the compilation of all the files. So you can see you have the Angular compiler to do the AOT transformation. We have moments to remove all the locales you don't want in your project. So you just keep the languages you selected during your JHipster generation. We provide you an HTML file if you want to analyze your bundle when it's generated. You just have to open it in Chrome. And this is the Webpack 4 new mode system. You have a mode for production with default presets, and you have a mode for development with development presets. So it's less lines of configuration than in JHipster 4. There is still a lot of things, but it's quite readable now, I think. Okay, next, we've set up the lazy loading in Angular. Why do we need to lazy load some things in our application? When a user comes to your page and is not an administration, I don't think he cares about waiting for the admin code. And maybe it's pretty big. You use an admin dashboard with a lot of graphics. It can be heavy to load. So a normal user, which will be 90% of your case, shouldn't have to wait to load all this code. So the result of that is that you have smaller files to load, and then so your application loads faster. And why do we care about those saved kilobytes when we are, why do we remove the moment locales and some bytes of the production code? I found an article on the Think with Google website who says if your pages take more than 3 seconds to load, the probability of bounce increases by 90%, and it goes on and on. So if your page loads takes more than 3 seconds to be fully loaded, you will lose a lot of users. So pay attention to your bundle size and to your page loading. Try the 3G mode on the Chrome DevTools to check if even on mobile and on slow mobile networks, your site is still responsive. I provided a link. There is a lot of interesting data in this article. So how do we do lazy loading in Angular? It's pretty easy. You first have to make sure you don't import the providers in various modules. I'll explain why later. You have to use the load children property in your routing, and you have to remove the feature module in your app module. So that's pretty easy. Why I said you shouldn't provide services in various modules, because if you do lazy loading, Angular will create one provider instance per lazy loading module. Imagine you provide your service in the app module and you provide the same services in the feature module, which will be lazy loaded. You will have 2 different instances of your class, which can lead to some surprises if you think your services are singletons. So the solution is to create a core module, which will be only imported in the app module, and this core module will have as providers all the singleton providers you want. And in JHipster 5, we already did this work. So if you want to check how this works, and if you migrate, please use the core module to provide your singleton services. So here is an example of the JHipster 5 Angular application. You can also apply this to any Angular application, I think. You have the core module on the top, which is imported only in the app module, which will be the bootstrapped module. And then you have some feature modules which will import the shared module. In shared module, we have the components, directives, pipes, and in the core module, we only have providers. Okay? So this is a pretty easy architecture, and we advise you to follow it in order to avoid surprises when for example, you store your user in the services. If you provide the same services in different modules, you will have the user in the one module and no user in the other. So follow this pattern and it will be easy. And this is the load children property that we use to tell Angular that we want, when the user access to an admin path, we want him to load the admin module. So if the user never access to admin page, he will never load the file. Then Webpack does his magic and will split all the code you have in the admin module into a separate file. Next, we added some optimizations, as I said, for Moment. Does anyone knows Moment or use MomentJS to manipulate dates? Yeah, I think it's the most famous library to manipulate dates in JavaScript. But by default, they give you all the countries bundled. In JHipster, we have the ability to know what countries you selected, what languages you selected. So we can remove all the locales you didn't selected to make your production build smaller. So I've shown you, and now Julian is very happy because his production build has gained 200 kilobytes. We also migrated from FontAwesome v4 to FontAwesome v5. Before, FontAwesome used style sheets, but now it was too easy. They use SVG with JavaScript to replace the Y tags. Now they didn't use CSS. They check your HTML and replace with SVG. It's quite good because the definition is better, but it's pretty huge. It's around 400 kilobytes with minification, and it takes around 3 seconds to load on 3G, so just 3 seconds waiting for icons is not quite acceptable for us. So the solution is we added in the vendor.ts file, which I think you already have it in JHipster 4. You have to specify the icons you want in a separate file before using them in your HTML files. So I know it's not quite easy, but we have to do this in order to make your application performant. So if you want to add a new icon, check this file, add it, and then you can use it in your HTML file. Finally, we migrated to Jest. Let's compare the two solutions. Who does front tests with Karma actually? Good. So Jest is the solution provided by Facebook to do unit tests with JavaScript. Instead of using a real browser like Karma does, it uses a virtual DOM using the JS DOM technology. By doing that, he can run tests in parallel, which gains a lot of time. Which is good also with Jest. It's one dependency. You have the runner, the framework, the syntaxes, the coverage reporting. It's an only one. So you have less dependencies to manage in your front-end application. And instead of running tests on top of a Webpack compilation, it uses a preprocessor, so it compiles code on the fly while running tests. So again, the big point for Jest is the performances. How did we migrate to Jest? We removed all the Webpack configuration we used for Karma to compile the files. We removed the Karma configuration, and we added the Jest config file. And if you have a JHipster 4 application and want to migrate, you can use the Jest code modes global package. You can install globally with npm, and it will migrate all the syntax you have actually in your test with the Jest syntax. And you can see those two links. It's the PR we made to replace Karma with Jest. And you have the migration guide on Facebook who tells you how to use the Jest code modes. So let's compare those two solutions. I have two applications. Okay. I don't know why. So I have 4 applications and 5 applications. So I will run Jan test here. I can give him some time because he will be late. So let's check. We have Jest on the right and Karma on the front. So Karma is waiting for Webpack. Jest is already running his tests. And it's done. While Karma is still waiting for Webpack. And I think we can let him wait. So you have also the coverage provided. And you have the JUnit report if you want to send them to Sonar. We fixed it yesterday, I think. So, yeah, there you go. So you can see you gain a lot of time, and during the npm install phase, which takes a lot of time, you don't have now to install PhantomJS because it uses a virtual DOM. So you don't have to install any browser to run unit test. So those numbers are quite the same as reported, and you will gain more time when you run Jest for the second time because Jest uses a cache and Karma doesn't. So you can tell me Jest use a virtual DOM. How am I sure that my browser will be still compatible with my code? The answer of that is that yes, Jest doesn't run the test in a real browser like Chrome or Firefox. But for us, the point of unit test is not to test the browser compatibility, it's to test your code, your logic in your code. So you shouldn't have to do compatibility tests with unit tests on the front side. If you want to test the browser, you can use Protector to run real end-to-end test with a real browser with real user actions. So, and moreover, on the top of that, TypeScript already compiles your code into ES5, which is handled in all the major browsers. I think 97%, I saw that on the Can I Use link. 97% of the computers are compatible with ES5. So I think today we shouldn't worry a lot about browser compatibility. It depends if you have to support Internet Explorer, of course, but I think I went pretty fast, so that's it for me. I don't have the time, so okay. Thank you.